Okay, here are the notes for this new section, graphing rational functions. Graphing rational, right? Copy all this down, take notes, don't just watch. Rational functions are also known as AKA. They're also known as rational expressions. So you'll also see them called this rational expressions. But the key thing is they both have this word ratio, right? Or the word rational. The word rational has what? The word ratio there refers to something with a ratio. And we know that the word ratio means what? It means something like a fraction, kind of like in a fraction form. We can see a ratio as a fraction. Okay. What I'm actually going to show you I'm actually going to kind of do a little backwards teaching. I'm going to show you the last part. The last part is how to graph. How to graph. There's a couple of parts in the beginning you're not going to understand. Okay, but don't worry, I'll show that in the next video. I want you to just know how to finish this up and how to do the graphing parts. So what you're going to have is obviously an XY plane. Right, we're going to be graphing all of these on an XY coordinate axis. Right, so let's draw a few of them out here, just real quick sketches right here, right? Okay, so this is the way that these graphs are going to look, and what's going to happen is not the X and the Y axis, but you're gonna be drawing these other asymptotes. These asymptotes it's another set of like a vertical line or a horizontal line. So you might have one, going like across this way, and you might have one going across this way, right? So you notice it creates another another vertical and like another horizontal line, but just like this has 4 quadrants, right? Just like this has 4 quadrants. Now we're gonna focus on the quadrants here. That these asymptotes are like these boundary lines that the graphs can't pass, but they're gonna help you as a guide to graph. Now the good thing about the graphs that they're gonna be easy to just sketch out, because the ones that we're gonna see here first, there's others that get more complicated. The ones you're going to see first, they're going to be on opposite diagonal graphs. So you either have, again, of the asymptotes, right? We're gonna ignore the XY axis and just focus on this. Look at the 4 quadrants, and what I'm gonna show you in this video is how to graph. So this is what's gonna happen. You're gonna have these asymptotes. And once you have these asymptotes, if you determine that a point over here is in this quadrant, if there's a point that's in this quadrant, everybody see this upper quadrant of the asymptotes here, then the graph's going to go like this, and it's going to go through that point. Oops. I'm going to get as close as I can to this line, but I can't pass it. It's going to look like a rounded corner, right? And like I said earlier, if there's one on this top diagonal, then there will be one on the, kind of like on the mirror symmetrical side of it over here diagonally, like this. All right. Similarly, what if I have my asymptotes again? You'll have a vertical asymptote. Actually, sorry, that's vertical. And let's say you have one like this. Wherever those asymptotes are, again, I have not explained what this is. I will show you in the other videos how to get these asymptotes, these other little boundary lines that I'm telling you. But once I have this and I see that it makes 4 quadrants right here, right? Ignore the XY axis. I'm going to show you right now how to determine if it's these two that there's going to be graphed on, or what if you determine that a point is here? Let's say there. Well, then it'll be what? On this bottom. It'll be like the graph will be here. It kind of look like a little, like a corner like this, and then the other one will be like this. That's how these graphs look. I mean, these that we're going to learn right now. So it's either going to be these two. If you figure out it's this one, then it's also this one. Or if you figure out it's this. And again, the asymptotes can be anywhere. I mean, that I'm going to show you later. So what if I have this horizontal asymptote down here, and now this one's going to be, you know, whatever on this side. Everything depends on the function, right? And I haven't showed you all that yet. Right now, I'm just going to explain to you how to get to the how to get these, how to know how to draw those curves and graph it. So here again, I'm just throwing it out there. I'm just like, okay, there's an asymptote there. There's an asymptote there. You guys see the four, right? And you do like a vertical and a horizontal line. It'll give you four quadrants here. And then let's say you do something and you figure out that the point is here. Well, then you know that the graph or the curve has to go through that point. So that means it has to be, right? We're going to get it really close to those asymptotes, but it never really crosses. And then that means that the other one is on this other side. Okay, so you just draw it like that. That's how it's going to look. They're either going to be on these two opposite quadrants, like these two, or they're going to be on these two opposite quadrants. The ones that we're going to see first. So now let me actually do a problem. And number one, f of x is equal to, and here's a rational function or a rational expression. See, you're going to have a numerator and a denominator. That's why it's a rational expression. There's a numerator and there's a denominator, right? Okay. So for this one, again, I'm going to explain them in the other video how to draw the asymptotes. I'm going to draw the asymptotes for you, okay? And actually what I'm going to do is I'm going to use a graph. Now I know you guys don't have a graph. Let me see. Should I use a graph? Okay, I won't. I won't because I know you don't have graph paper yet. Okay. So this is what you're going to do. Let me just go ahead and draw these asymptotes right now. Again, I know I haven't taught you that. I'll explain that later. I'm just showing you the last part, how to graph. Okay, so let's say there's one up here. And then there's one over here. Okay, for this graph. So let's say you draw the asymptotes, kind of like dashed lines. They're supposed to be kind of broken lines, but I'm kind of going quick, right? Just to show you. These are the asymptotes. Now you see how they create four quadrants like this? Okay, this is the way you're going to determine if it's the graphs or the two curves are on these two diagonals or if they're in these two diagonals. Here we go. What you're going to actually obviously use is this function. So here are the steps. Step one, we're going to choose a value for x. What's the easiest value for x on this function? Step one, choose let x equal 0. That's the easiest one. We're going to substitute. I mean, you could pick any value of x, but the easiest one to work with is 0. So if I substitute, which is going to be now step 2, if I substitute wherever I see a x into, well, let me write it again. F of x is equal to x plus 6 over x minus 2. If I substitute everywhere there's an x, I put a 0, that would look like what? Well, that would be 0 plus 6 over what? 0 minus 2. And not only that, do you remember that for f of x, that's also like y? Like that's our y, but when they're functions, they use these fancy letters, but that's kind of like really like your y. I'm gonna let x equal 0. Well, the x's are over here. Don't put it over here. Right here. Yeah? Well, when x is 0, you're gonna get 6 over negative 2. That means you're gonna get y is equal to what? Negative 3. What does that mean? What does that mean? Well, let's see. On this side of the function is your x, or your x's will be here, and this is the y, right? Okay. So if you said x equals 0, when you plugged in because you can pick any point you want on the x. When you chose, or we choosing x equals 0, we got negative 3. So this is a point. When I picked x equals 0, I got negative 3. That means this point is what? Well, obviously for a coordinate, I need an x and a y. 0 for the x, negative 3. That means at this point, 0, negative 3, this point is on the graph, right? Because I substituted into this function, I got 0, negative 3. So let's plot where 0, negative 3 is. 0, start with 0 on the x. That means I go nowhere on the x. And I go up 3. 1, 2, 3. 0, negative 3. Well, 1, 2, maybe 3. I don't know, right here. This is the point. 0. Oh, what am I doing? That's not 0, negative 3. Oops. Oopsie, that's wrong, huh? What's wrong with you? What's wrong with me? That's not 0, negative 3, right? I got to go back to my xy axis, starting here at the origin. 0, 0 on the x, negative 3 is down this way. Oops. Right over here. Well, let's see right here. Okay, so that means that the graph is on this quadrant. That means that the curve is in this bottom quadrant, so that means that, and if it goes through this point, it must be looking like this, right? Make it nice and curvish. Right, it goes through that point. And that's how you know. And if I have a curve on this part of this quadrant, then the other one is also what? Over here. Yeah? So that's how you determine. You're going to pick x equals 0, and then you're going to substitute it in. And for this problem, I put x equals 0, and I got negative 3 for y. So that's the point I plotted here. I go back to my xy axis. I plot it 0, negative 3. And that point is on the graph. And if there's one, or on the curve here, and if this curve exists here, then the other one's over here. Now, what would have happened if this was a positive 3? If this was a positive 3, I would have had the point here. Then that means the curve would have been one here, and then the other one over here on this side. You see? Let's do another one. Actually, let me stop this video, and then because I don't want it to be too long, and then we'll do the other two on the next video. Please watch the other videos. This was a simple one.